Alright guys, in lesson 2 we're going to be talking about classifying numbers, specifically rational numbers, but we're going to talk about all the classifications. Then we're also going to talk about how to convert a decimal into a fraction, since last section we talked about how to convert a fraction into a decimal. Okay, so on this first slide here, we're going to talk about our different classifications. So when you first learned to count using the numbers 1, 2, 3, etc., etc., you were using members of the set of natural numbers, which we could also denote with a capital N. So the natural numbers, which we use the capital N as. If you add 0 to the set of natural numbers, the result is a set of whole numbers, which we use the W for. So capital W for whole numbers. Again, your natural numbers and your whole numbers are pretty much exactly the same thing, except that your whole numbers include 0, your natural numbers do not. So then whole numbers and their opposites make up a set of integers. We talked about integers last chapter. So still no decimals or fractions, but now we are including negative numbers, but they do not have to be negative. And we call the set of integers Z. First one that doesn't quite make sense there, so capital Z is our integers. And then any number that can be written in the form of A over B, where A and B are integers and B does not equal 0, is part of the set of rational numbers. So this whole chapter is about rational numbers. We use a capital Q for rational. Basically, we're looking at anything that can be written as a fraction. Can be a rational number. So whole numbers, integers, natural numbers, they can all be written as a fraction. For instance, if I have a 6, we could rewrite it as 6 over 1. So anything that can be written as a fraction, again, is a rational numbers. And then decimals that can neither terminate nor repeat are called irrational numbers. So irrational numbers cannot be written as a fraction. So rationals are fractions, irrationals cannot be written as fraction. If you look in our chart over here, if you start on the inside, you want to go to your innermost, because if it is a natural number, then it is also a whole number, it is also an integer, it is also a rational number. If it was just an integer, so if we saw a negative, then it can't be whole or natural, but it is also a rational number. So if you remember this chart, and you go to the innermost circle that you can, then just work your way out, and you'll get the rest of your classifications. So let's do an example of classifying. We want to identify all sets of numbers to which 2.55 belongs. And you're given real, rational, irrational, integer, whole, or natural. Okay, so 2.55. As soon as I see that decimal, I know it cannot be natural, it cannot be whole, and it cannot be an integer. Because these guys cannot be decimals or fractions. So now I have to decide, is this going to be rational or irrational? It has to be one of these. It cannot be both, but it must be one of them. So if we flip back here real quick, some examples of irrationals would be pi or a square root that is not a perfect square. We'll talk about them more later and not how to look at them on your calculator, but just know that we're looking at pi and square roots. So how could I decide if I can write 2.55 as a fraction? Well, if you say 2 and 55 hundredths, so hundredths tells me I could rewrite this as a mixed number, so 2 and 55 hundredths, which does reduce, but right now I'm just trying to classify. So this tells me I have a fraction, so it is rational. And then everything that we work with this year is real, so always write real. So 2.55 or 255 hundredths would be rational and real. At our next example, 1 gallon of water is equivalent to 8 8.34 pounds. Write this value as a mixed number in simplest form. Please make sure we always do simplest form. You will lose credit if you do not simplify. So again, 8.34 we would say as 8 and 34 hundredths. So I know I have an 8. 34 hundredths, so 34 over 100. Now I have to think about simplifying. I see 34 and 100. I know they're both even, so I know that I can divide both my numerator and denominator by 2. 8 stays the same, so 34 becomes 17, 100 becomes 50. So 8 and 17/50ths, which does not simplify any further. So 8.34 as a mixed number in simplest form would be 8 and 17/50ths. Okay, a little bit of wrap up here. Writing numbers as rational numbers. So our first box are natural numbers. So we have 1, 2, 8, 50, etc., etc. It's your counting numbers. So you could take any of these numbers. So to write as a fraction, we could take any of these numbers like 50 and just write it over 1. Your wholes and your integers, same thing. Wholes, we're going to add 0. We can take any of them again over 1. Integers, we add in our negatives. Again, any of them written over 1 gives us a rational number. Okay, so mixed numbers. Think about 7.12. 7.12. We could rewrite as a mixed number as 7 and 12 hundredths, which we would reduce to 7 and 6/50ths if you divide by 2, which we could then reduce again to 7 and 3/25ths. Okay, now terminating decimals. Let's get a little practice here. If we give you 0.7, we would say that as 7/10. So as a fraction, 7 over 10. If we gave you 0.85, now we're talking about hundredths, so 85 hundredths. So 85 over 100, which then reduces to 17 over 20. We could keep getting larger, so 0.8926. I now see 3 decimals, so now we're talking about thousandths. So 926 over 1,000, which reduces to 463 over 500. Basically what we're doing here is how many decimal places do I have? That's how many zeros I start with. So I had 2 decimals, 2 zeros, 3 decimals, 3 zeros. Keep that in mind because we're going to use the same kind of idea for repeating decimals. If I give you 0.3 repeating, I have 1 digit that is repeating. So I am going to rewrite this as 3 over 9. So here we think 0, repeating we think 9. Now this does reduce then to 1/3. So if we said 0.12 both repeating, I now have 2 digits repeating, so 12 over 99, so 2 9s. Which they're both divisible by 3, so 4 over 33. If we said 0.827 all repeating, now I have 3 digits, so that is 827 over 999. Which actually does not reduce. So take away that arrow. And we will talk about how we can quickly reduce on our calculators in class. All right, guys, so there's the end of our notes. The rest of this I want you to try. So we have 2 of them where I want you to identify all the sets to which each number belongs. So we have 15 and negative 5.075. And then 2 examples where I want you to write the decimal as a fraction or mixed number in simplest form. Make sure you do simplest form. So convert 0.42 and 0.8 repeating into a fraction in simplest form. All right, that's it.